continue with the next surface, which is a quadric surface. Okay, so in general form, we have this equation, right? Ax squared plus by squared plus cz squared and so on, and equal to 0. Okay, so basically the quadric surface. Okay, so we have three different quadric surface, which is ellipsoid, hyperboloid and paraboloid. Alright, so now let's look at the equation and the what we call that, the shape. Okay, alright, so now okay, so we have ellipsoid here. Okay, so it is an ellipse. Okay, the trace, okay, the traces will be ellipse. Okay, so if we look at the equation here, okay, so the equation is we have x, y and z. Okay, so meaning that there are no variable missing, so that's why we need to have three traces. Okay, and all the traces got ellipse. Okay, so in this case you need to know what will be the standard equation for the ellipse. Okay, so as I mentioned before, okay, so if we okay, so maybe it's not so clear. Okay, so you need to check back. Okay, so the standard equation will be the x minus h squared, okay, plus this one here, okay, plus y minus k squared over, okay, so add x over a squared and then y b squared equal to 1k. So and then here we have b at the b squared at the a and at the x, and a with the y. Okay, so basically it's the different. Okay, so for this case is a is the major axis. Okay, so which is a is greater than b, the a squared is greater than b squared. Okay, so that's why if you know that the bigger number is under x, so meaning that it will be horizontal. Okay, so when okay the bigger number is belong to y, so it will be vertical. Okay, the ellipse. Okay, so you need to know the difference lah. Okay, alright, so a is basically the length, okay, the radius, okay, from the center hk to the vertex. Okay, so same goes for this one lah. Okay, so this is a because that one is longer. A is bigger number than b. Okay, so that one is ellipse, so you need to look at back the standard equation for ellipse. Okay, so this one is hyperboloid. Okay, hyperboloid of one shape. Okay, meaning that we only have one shape which merge. Okay, so in this case again we have the standard form here. We have x, y and z, which is no variable missing, and that's why we need to have three traces. Okay, which is hyperbola. Okay, for x, y, z plane, it is hyperbola. Okay, sorry. Okay, so it's hyperbola, so it will be like this. Okay, and z plane also hyperbola. Sorry, okay, hold on. Hyperbola and okay, either this one or this one. Okay, so we don't know which one. Okay, so this one or this one. Okay, and also one more is ellipse. Okay, so ellipse is either like this or like this. Okay, so depends on the standard equation lah. Okay, so what is the standard equation of the hyperbola? How we want to know that whether it is horizontal like this or vertical like this? Okay, so still we have the standard form. Okay, so if we have the first one here, okay, alright, so it is vertical. Okay, so vertical hyperbola. Okay, so we have the x here. Okay, sorry, the negative here. Okay, so when we have the negative belong to y, okay, so meaning that it will be horizontal. Okay, so when the negative is belong to x, so it will be vertical. Okay, a and b is basically is the length between the vertex and the center. Okay, so in this case center is hk lah. Okay, hk. Alright, H is refer to X, K refer to Y. Okay. Alright, so you need to look at back the standard form. Okay, so it's really important because you want to sketch, okay, for the trace, for the hyperboloid, okay, of one shape. Okay, now let's look at the next shape. Okay, so hyperboloid of two shape. Okay, so we have a separate hyperboloid here. Okay, alright, so we have this standard equation. Okay, so X got negative here. Okay, and we still have no missing variable, so that means we need to have three traces. Okay, so hyperbola either like this or like this. Okay, another hyperbola, okay, another ellipse. Okay, for the traces. Okay, now elliptic cone. Okay, so this is the standard equation. The z is negative. Okay, so we have no missing variable. We still have three traces. Okay, so hyperbola, and ellipse also. Okay, alright. So now next one, elliptic paraboloid. Okay, so in this case, paraboloid. Okay, so we need to know this is the standard equation. Okay, z is negative and z is not equal, not squared lah. Okay. So we have three traces because no variable missing. So the traces are parabola and also the ellipse. Okay, so we already know the ellipse, the standard equation for the ellipse. Okay, so how about the standard equation for the parabola? Okay, so parabola here, if we look at here, the first one here, if we have y equal to 4ax, so meaning that is open to the right like this. Okay, so when we have y squared but the negative x, okay, so it will be open to the left. Okay, when x squared, okay, so it will be upward. Okay, when x squared but it is negative, okay, it will be open downward. Okay, so you should know this. Okay, the standard equation for the parabola. Okay, you need to remember back. Okay, alright, so next equation. Okay, so it is hyperbolic paraboloid. Okay, so the standard equation given here is for y is negative, z is degree 1. Okay, so we still have 1, 2, 3 traces. Okay, parabola and hyperbola. Okay, so the parabola, it can be like this, it can be like this, it can be like this, or it can be like this. Okay, open to the left, open to the right, open to outward or downward. Okay, so it can be like this also, upward, downward, to the right. And then the hyperbola. Okay, the hyperbola is like this or like this. Okay, so you can see the shape here. Alright. Okay, so that's why you need to know the standard equation, alright, for the parabola. Okay, so because you want to trace. Okay, so it's really important. Okay, after that you need to merge, right? So the first is of course the trace. Okay, so now we want to sketch the quadric surfaces just now, ellipsoid, hyperboloid and paraboloid. Okay, so now we should know the level curve. Okay, before this, for the plane, okay, for the flat surface, for the plane surface, yeah, and also the sphere. Okay, another one is what do we have before? Another one is, oh my god, I forgot already. Okay, what is the shape? Okay, never mind. Okay, cylinder. Okay, forgot already. Cylinder. Okay, and then so you don't have this like level curve. Okay, but basically you have the level curve. You project, when you project, you have another level, right? So that one is another curve basically you create, but you did not mention any value for that, right? You just make it because all the shape for all levels are same. Okay, for the previous shape. Okay, but for this quadric surfaces, okay, so we need to have level curve because at the each level the curve is different. The curve is maybe wider or maybe smaller. Okay, alright, so definition: a level curve of a function f(x,y), okay, is the curve f(x,y) equal to c. Okay, so we make it a level curve, and the level curve here is we make it equal to constant, okay, to xy plane. Okay, remember xy plane. Okay, this level curve is created at xy plane. Okay, it is consists of the point where the function has the value c. So we can determine the value of c. C equal to 0, 1, 2, or c is equal to negative, and so on. Okay. Contour map. What is contour map? Okay, so basically it's a set of level curves. So we have one level curve, we have two level curve, we have three level curve, and all of that we call it as a contour map. Okay, remember it is on the xy plane. Okay, so for example, let's say we have, okay, so his x, y, and z. So let's say we have one level curve, okay, and then we have two level curve, and then we have three level curve. For example, it is on this xy plane. Okay, so we call this as a contour map. A set, okay, a set of level curve is called contour map. Okay, so how we going to sketch this graph? Okay, using the level curve. Okay, so of course we need to find all the three traces first, and then we need to sketch the surfaces for all plane, and we need to combine. Okay, alright, and then we need to find, okay, so basically all the traces here, of course we need to find the y plane, okay, but we need to determine the value of z here. Okay, so for normal, for the previous example, for the xz plane, yz plane, okay, so we need to determine based on the value from the equation. So for example, like for the previous, for example, x equal to 0, y equal to 0, okay, and then z equal to 0. Okay, so but sorry, it's not z, so here is y, okay, here is x value. Okay, so let's say x equal to 0, y equal to 0, but this time z equal to c. So it can be z equal to 1, z equal to 2, z equal to 3, depends what value that you want to put. Okay, so meaning that we have more than one value for the z. Okay, alright, now let's look at the first example. Sketch the level curve or curve, yeah, as, okay, or we call it as a contour map of the following function. Then sketch the traces and hence the graph. Okay, so now we want to look at the first equation here. Okay, z equal to x squared plus y squared, and here we want to have the level curve for c equal to 0, 1, 4, and 9. What is c? C is the value for z. Okay, where is it? At the xy plane. Remember, it is at the xy plane. Okay, alright, so now we want to look at the first one. Okay, so we know that from here, okay, so it's given here it is a paraboloid. Okay, but okay, is it true? Okay, so now let's look at the equation here. Okay, alright, so now we want to have, okay, let's make it a bigger size first. Okay, here we have z equal to x squared plus y squared. Okay, so we want to have the traces. Okay, let's say first we make it as equal to 0. Okay, because we need to have three traces, because all variable are here and no variable missing. Okay, so it will be z is equal to y squared. Okay, so what will be the graph? Okay, so if we have the graph, okay, so it will be y and z lah, okay, y and z. So z equal to y squared, so meaning that our graph will be smiling like this, right? So this is z equal to y squared. Okay, so now how about y equal to 0? Okay, then we have z equal to x squared. Okay, so this time our graph is on the plane of what? X and z. Alright, so what would be our shape here? Okay, still smiling. Okay, so z equal to y squared. So we have like this. Okay, alright, so now last one here. We want to have the xy plane, which is for the z equal to 0 plane, right? Okay, so we have 0, okay, meaning that x plus y squared equal to 0. Okay, so for this case, we know that it will be, what shape is this? Let's say we have x and y plane. Okay, so what will be the graph? Okay, it is x squared plus y squared equal to 0. Suppose it's a circle, right? So yes, it is a circle, but we have the radius of 0. Why 0? Because it is radius 0. So it will be just a dot, just a circle here, radius 0. Okay, so let's say x squared plus y squared equal to 4. So meaning that the radius is 2. Okay, when radius is 2, of course we can draw a circle. 2 minus 2 minus 2 if x squared plus y squared equal to 4. But now it is x squared plus y squared equal to 0. So yes, it is just a dot. Okay, alright, okay. So now we want to combine all these traces. Okay, so now we will have axis of x, y, z, right? Okay, so now let's look at the first one. Okay, z equal to y squared here. Okay, so let's choose. Okay, so yz plane. Okay, yz plane. Okay, which is at the front wall. Okay, so it will be like this, right? Okay, so we have, okay, alright, for xz plane, meaning that we have the side wall here. Okay, so it will be, okay, just now you are at front wall, so meaning that you are looking from x-axis. Okay, so when for the side wall, meaning that you are standing at y-axis, right? So you will look at the side. Okay, so basically it's the same shape, just because you're looking from the y angle. Okay, so that's why it's a little bit like that lah. Okay, alright, so now for z equal to 0, you will have a what? A dot. Okay, so you are standing at z-axis here, and you're looking down at the xy plane, which is on the floor, and you just look at a dot, okay, on the floor. Alright, so now what you need to do is you need to do a level curve. Okay, because these traces are not complete. Okay, we don't know how we want to merge this. We only have two what we call this, two parabola and then one dot. Okay, we cannot merge. Okay, so that's why we need to have a level curve for xy plane. Okay, so what is xy plane? Okay, so we have just now xy plane is this one for z here. Okay, so now, okay, we will have z equal to 0. So now we need to increase the value. Okay, z equal to 1. Okay, so is that okay, 0149, 0149. Okay, that what we call, okay, z 1, 4, 9. Okay, so z equal to 1. So meaning that x squared plus y squared equal to 1. Okay, alright, and then just now we already have 0, right? Okay, so now we need to do z equal to 4. Okay, so for z equal to 4, it is x squared plus y squared equal to 4. And then z equal to 9, so it will be, so basically it is equal to 2 squared, yeah? So x squared plus y squared equal to 9, which is equal to 3 squared. Okay, so, and so on lah. So basically, what we will have here is, let's try. Okay, what we have here is for x squared plus y squared equal to 1, meaning that we will have a radius of 1. 1, 1, minus 1, minus 1. Okay, so for x squared plus y squared equal to 2 squared, for z equal to 4 is radius 2. Okay, 2, 2. Okay, so for z equal to 9, okay, we will have x squared plus y squared for 3 squared. Okay, which is radius is 3. Here. Okay. Alright, so basically what do you have here? It is a circle. Okay, it is a circle. Okay, so now we need to label. Okay, this is the contour map. Okay, the label of, okay, so this one here is when z equal to 0. Okay, the second line there is when z is equal to 1. Okay, so this one is when z is equal to 4. And this one here, the last one here is when z is equal to 9. Basically, we can go further. Okay, and basically it will be a circle, a shape of circle. Okay, so now what we need to do? Okay, we need to merge. Okay, so we need to merge, we need to map, okay, this level curve or the contour map, okay, at the 3D graph just now. Okay, so basically, okay, we will have from the z angle here, so we are sitting here. Okay, so at z equal to 0 is here. Okay, and then at z equal to 1. Okay, so let's say you will have a circle when z equal to 1. Let's say z equal to 1 there. Okay, so it will be a circle. Okay, for this one, when let's say here 1 lah. Okay, and then you have z equal to 4. Let's say 4 here. Okay, and you have a circle. You can see from your z here. Okay, okay, it is on the xy plane. So z, okay, so it is z value is 4. Okay, and then let's say here is 9. Okay, so you can see, okay, so maybe it's higher. Okay, so it will be like that. Okay, hopefully you can understand. Okay, so that is the shape. Okay, the paraboloid. Okay, so of course for this case we need to have a level curve, or we can say that all of these level curve make a contour map. Okay, so these are the level curve, and the set of the level curve is the contour map. Okay, alright. Okay, so now let's look at the next example. Okay,